Okay, welcome back. Let's continue the example in our notes. Let's notice that the next problem is looking for a missing angle. So in this case, I actually want to switch to my inverse formulas at the bottom of your notes. And I'm still going to label my triangle the exact same way. So here's my angle that I'm looking for. 39 is my hypotenuse. Okay. 36 is still my opposite side because it's across from the angle I'm looking for. And this side here would be my adjacent, except I don't really need it in this case, so I'm just going to leave it blank. And here I have the opposite and the hypotenuse, so it would make the most sense to use this first formula, inverse sine opposite over hypotenuse, and that's called inverse sine. That's how you read that. So what you do, and this is actually easier than the first problem, is you literally write theta equals, theta is same thing as question mark, that's what we're looking for, inverse sine, and I always put these in parentheses actually, opposite, which is 36 over 39. And you literally type this in your calculator and out comes an answer. So just so you can see where that button is on your calculator, I just want to kind of show you my calculator. This is old, but it'll still work. Inverse sine, you want to go to second, and inverse sine is this yellow button. It looks like that. Okay, whoops, I need to turn it on first. That would help. Sorry. Okay, so second inverse sine, and that's what it looks like. And you literally type in 36 divided by 39 and parentheses, and you can see it gives you an answer. So my answer here is 67.4 degrees. You could just say roughly 67 degrees, okay? Now, if you're using a cell phone, there should be an inverse sine button, so make sure you can figure out how to get 67. I believe with the cell phone, you might have to type in the ratio first, then hit inverse sine. So you might want to either Google that or play around with it if you don't have a scientific calculator. Okay, let's go to the next example. This is down here. Let's just actually notice the fun fact that this right triangle is actually a Pythagorean triple, right? This is a 5, 12, 13 triangle. So just note that, it's coming in handy. Okay, I don't know that we necessarily need to know that hypotenuse, but that would be the case. And again, I'm going to label this the same way, right? So 5 is going to be my adjacent because it's next. Oh, sorry. No. Sorry. 5 is going to be my opposite side. Okay, sorry about that. 12 is going to be my adjacent, and my hypotenuse, I don't need to label. If I'm looking for the missing angle and I have the opposite and the adjacent, it makes the most sense to use the inverse tangent formula because the other formulas won't have the ingredients that I need. So again, I'm going to literally write down theta equals inverse tangent of opposite over adjacent, so 5 over 12. And I'm going to literally type that in my calculator. I'll show you again what that looks like. So if you have this type of calculator, so inverse tangent of 5 divided by 12, and it should give you roughly 22.6 degrees. Okay, so something along those lines. I don't really care how you round right now, as long as you're getting roughly the same answer. Okay, and our final example, let me just make this a little darker. This is a 12, this is a 9. So theta is the angle I'm looking for. This is my adjacent. This is my hypotenuse. I don't have the opposite side. So in this particular case, it makes the most sense to use the cosine formula, inverse cosine, because I have the ingredients in the formula. So I'm going to say that theta equals inverse cosine of adjacent over hypotenuse, okay? Now, just a little fun fact, 9 over 12, you can reduce that fraction. You don't have to. You can type it in the calculator as is. However, you'll get the same result if you reduce the fraction because we can make similar triangles out of these ratios, right? So if I knew this was 3 and this is 4, I could make a similar triangle that's smaller than the original, and the sides would be in the same exact ratio. So that's kind of like a cool fun fact or trick. And what's also interesting is that the angle theta doesn't depend on how big the triangle is. You'll get the same exact angle measure whether you have a small triangle with sides 3 and 4, or whether you have a larger similar triangle with sides 9 and 12. So either one works. You type that in, you'll get something along the lines of 41.4 degrees. I hope you found that helpful. And the next video will talk about how to use these in more difficult problems.